Hello students, welcome to another pre-calculus class. Today we look at section 1.4. Let's start with a few definitions. First of all, let's talk about a line. A line is a set of coordinate pairs x, y, where the change in the y is proportional to the change in x. The constant of proportionality or slope is given by the letter m. The slope of a line between 2 points x sub 1, y sub 1, and x sub 2, y sub 2 is found by m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, provided the denominator is not 0. Note the order in which we do the subtraction is very important. So we have y sub 2 minus y sub 1. It's essential that at the bottom we do x sub 2 minus x sub 1. If the slope equation were written m was equal to y sub 1 minus y sub 2, the denominator would have to be x sub 1 minus x sub 2. There are two forms of writing a line in this section which we will look at. The first one is the point slope form. That is y minus y sub 1 is equal to m times x minus x sub 1. M here is a slope, and x sub 1, y sub 1 is any point on the line. Then there's a slope-intercept form, which is more common to see. That so form y is equal to mx plus b. Here m is a slope, and b is your y-intercept. Let's look at an example. Find the point slope form and also slope-intercept form of the same line that satisfies the conditions through a point A, 5, 2, and B, negative 7, 1. Now, first of all, I want to find the slope of that line. We use our formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we have to assign to these numbers that are given x sub 1 minus y sub 1 for point A, and x sub 2, y sub 2 for point B. Now, it really doesn't matter which one you assigned, the x sub 1, y sub 1, x sub 2, y sub 2, as long as you make sure it is in the form x sub 1, y sub 1, x sub 2, y sub 2. Now we can replace the y sub 2 in the equation with 1 minus y sub 1, which is 2, over x sub 2, which is negative 7, minus x sub 1, which is 5. And then simplify this, becomes negative 1 over negative 12, which is equal to 112. So slope here is 112. Now for the point slope form of the line, remember that was y minus y sub 1 is equal to m x minus x sub 1, right? So we keep our y minus, we replace our y sub 1 with 2 is equal to m, which is 112, parentheses x, we keep our x as x, minus x sub 1, which it chose to be 5. And so this is our equation in point slope form. Next, we want to write in slope-intercept form. Slope-intercept form is the form y is equal to mx plus b. Okay, now if you want to go directly from point slope form to slope-intercept form, all we need to do is to rearrange this equation so that your y only is on the original, is on the left side. So from point slope form, let's do it this way. We have y minus 2 is equal to 112 x minus 5. We will try to expand this and then simplify, so y minus 2 is equal to 12x minus 5 over 12. Continuing, add 2 to both sides. We have y is equal to 12x minus 5, 12. And this 2 we can write in terms of 12s. So make that 24 over 12. So finally, y is equal to 112x plus 19 over 12. And that is your answer in slope-intercept form. Okay, so this is what we got from going from point-slope form. Now, suppose we did not want to go from point-slope form. We just wanted to go y is equal to mx plus b, and then go from the original. If we wanted to go from the original, we would just choose either of point A or point B for your x and y replacement. So let's choose point A. Let's say point A was your x and y, right? And this is for your SI form, right? So that is your x and y for the SI form, not for the point slope form, but for the slope-intercept form. So replace this y with 2 is equal to m we already calculated was 112. That's 112x plus b. But we know that b was, we know that x was 5. So that's going to be 512x plus b. So 2 equals 512 plus b. And so b would be equal to 512, right? So b minus 2 minus 512, which is 2412 minus 512. So that's going to be 1912, right? So we found b. After we found b, replace b in the original formula. So replace b in original formula. We keep our x and our y and replace our m. So in this case, y is equal to 112x plus 19 over 12, right? Which is the same answer which you would have got, that we got when we did it, the slope-intercept form coming from the point-slope form. All right? Okay. Let's look at some other examples. Okay, so we asked next to find the slope-intercept form of the line 3x plus 4y equals 4. And so the slope-intercept form again we said was y is equal to mx plus b. And so 3x plus 4y is equal to 4. We want to have y only on the left side, so what we want to do is that we want to rearrange equations so y is on the left side. Y only is on the left side. The left. Okay, so we subtract 3x from both sides. 4y is equal to negative 3x plus 4. And we divide both sides by 4. So it's just a bunch of algebra. We have y is equal to negative 3/4 x plus 1, right? And that is your answer for writing the line in slope-intercept form or SI form, okay? The next thing we want to look at in this situation is something called average rate of change, right? So if we have a curve, y is equal to f of x, and we draw a line through that curve so that it cuts the curve into 2 points, x sub 1. Originally, it had x plus 1, x sub 1, y sub 1. Now, because we're using y is equal to f of x, slightly rename that point to be x sub 1, f of x sub 1. And the second point, x sub 2, f of x sub 2. So we're coming from the slope. Remember, we had slope was m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This line we call a secant line that cuts the curve, the blue curve. We call that a secant line, so we want to find the slope of the secant line. And because we had named our secant line the points that it cut the curve at x sub 1, f of x sub 1, so instead of y sub 2, we will have f of x sub 2. And instead of y sub 1, we'll have f of x sub 1. All that will be over x sub 2 and x sub 1 remain the same, so x sub 2 minus x sub 1. So that is a formula for the slope of a secant line, right? We're thinking about the rate of change on the curve, and notice as we move, if we move the points, it really doesn't matter how you move the points. What the secant line gives is the average rate of change, right, between 2 points. So the average rate of change, or ARC, or your average rate of change, is just the slope of the secant line, which is f x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, right? So average rate of change, the slope of the secant line between 2 points, right, on a curve, is given by the formula f of x sub 2 minus f of x sub 1, or x sub 2 minus x sub 1. Let's look at an example real quick. Find the function f of x is equal to x squared minus 1. Determine the average rate of change. So ARC is equal to f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So that is going to be the f of, let's say, x sub 2 was 0. So that's f of 0 minus f of x sub 1, which was negative 2, over 0 minus negative 2. All right, so let's plug in f of 0, plug in 0 into x squared minus 1. So that's going to be negative 1. And then the f of negative 2 will be negative 2 squared. Is minus, that's going to be 4. 4 minus 1, that's 3. So that's negative 1 minus 3 over 2. So it's going to be negative 4 over 2, which is equal to negative 2. So your ARC here will be negative 2. All right, so that is how you find your average rate of change between 2 points. Again, you use formula f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 to find the average rate of change. And in this example, we got negative 2 as our average rate of change, right?